Hello everyone, welcome back to the Leetcode Grind. Today we have a problem that is asked on site at Meta, mm, and it is a medium problem. It's a fixed 5 smallest subtree with all the deepest nodes. It says here, given the root of a binary tree, so we start at the root, the depth of each node is the shortest distance to the root. Okay. Return the smallest subtree such that it contains all the deepest nodes in the original tree. A node is called the deepest if it has the largest depth possible among any node in the entire tree. The subtree of a node is a tree consisting of that node plus the set of all descendants of that node. And we can give this a go. Okay, so I have this drawn out over here, and I thought we could kind of go over our strategy. Our strategy is to go over from the root node, so we replicated this here, and uh, expand our search and get our deepest node by tracking, every time we go down, we're going to see if it's none, it's 0. If it's here, it's 0 plus 1. This is level 1, this is level 2, root is at level 3, like that. And as for the actual node, we'll do that by returning the node, which is deeper. And this will make more sense once we go over the approach. So our approach is to go from the root node and then go downwards, starting from the left. Now our base condition, first off, is if we reach the end and it's a none, if it's a none, we'll return 0 for the height, for the depth. And instead of saying root is at 0, this is 1, we'll go in reverse order and say if it's none, that's 0, and return none. Then for each, we'll exhaust the left side, we'll exhaust the right side, and then from those two results, which will be two tuples, one from the left, one from the right, we'll take whichever has the deeper height or the deeper level, and then continue on with whatever node is returned from that deeper level. Now, assume that these end up being the same. If both heights are the same, then instead of returning either of the nodes, we'll return the root from which these two are its children, which are not. Okay, so let's give that a go. Let's start at the root, and this has a left, so we go there. We check the left. Left is 0 and none. We go back. We can go to the right, 0 and none. So when we return here, 0 and 0 is the same. So instead of returning either, none or none, we return this, the current value, the root, and plus 1 to indicate that we jump back up and this is now a different level. So I'll say return 1 and 6. And make that a little cleaner. And 6. Okay, and then we go to the right has a left, we go left, left once again, this is an X. So then we go back to the parent, we go to the right, this is 0 and none, same height, so we return here 1 and 7. We go back to the root goes to the right, checks the left is none, the right is also none. The heights of both nuns are 0, so they're the same. So we return 1 to indicate that we have one level, and then the root. Okay, So even up until here, it's the same. We have, well, actually, let's do this properly. We're back here. So what happens? We jump here. Okay. So here we'll say, you know what? 1 and 1, same height. So instead of returning either 7 or 4, we return the root. So 1 and always add we're jumping back up. So +1 the level. So we're returning 2 and the node, the root, which is 2. Now here, this is our first scenario where the heights are different. We have a 1 and a 2. So far, all the other heights thus far have been equal. So we've always returned the root, right? These are the roots. We never return the nodes associated with it. This is the first instance where this height is greater than this height. So instead of returning the root, we actually return the node that is associated with the deeper height or the deeper level. Okay, so here, instead of returning, so first of all, we return the height, the larger height, which is 2 plus 1. Let's say that's going to be 3, and then the node will be 2. Okay, so we've exhausted the left half, the left subtree of 3, so we can now finally start the right. We're here at this node, which has a left. Let's start from the left. Check the left. It's a 0 and none. It's a 0 and none. Similar situation. The heights are the same, so we pop out to return the node. The height is incremented from here, so that's 1 and 0. We pop back, we pop here. Here has a left, which is nothing. This also has a right, which is nothing. The heights are the same, so we return 1 and 8. And then these heights are the same, 1 and 1 are the same, so we return 2. And because the heights are the same, we return the root, which is 1. And here you'll notice that the height of this guy is larger than this height. So we favor this one and ultimately return its relevant node. Okay. So this is one of the situations where I'm not sure if we should have written the code first or gone over this first, but hopefully it makes sense. And then now we can go over the code. So let's see, what do we do here? First of all, we have a function that takes in some node, and it's going to return some tuple, some something. We'll just say pass for now. And then we're ultimately calling it on starting from the root, and then we get some two values. So return DFS starting from the root. We're gonna get two values, which is the height and then the node associated with that height. So we want its second value. So 0th index has the height and the 1th index has the related node. Now let's work on this. So we have our DFS function, and then our base condition is if node is none, then we just want to return 0, saying that that's at level 0, and none for the node. Now otherwise, let's check the left side. Let's call that left height, left node is going to be DFS, and to the left subtree. Right height, right node is going to be DFS, and to the right subtree. And then if the left height is equal to the right height, then remember if the heights are the same, we return the node, the root that ties the equivalent heights, the equivalent depths. Okay? And so here we're going to return the node followed by the height. So they have the same height, so we'll return either of these two heights, which are the same in this case, if it's the same in this case, and the root, which is none. Otherwise, let's say that the left height is greater than the right height, then we return the deeper height plus 1 because we're always popping back up. And then, this is key, we return the left node. We don't return the root, we return the corresponding left node, which has the deeper height. So let's do that. Now, otherwise, this is if the, the right height is deeper than the then we return right height plus 1 and the right node. So we'll always return a tuple, which is some height and a node associated with that height. And then we ultimately want to return whichever node is associated with that deepest height. Okay, let's give that a run and submit. And there you have it. That's pretty good. This is once again 865 smallest subtree with all the deepest nodes. It is asked by Meta on site, and thanks so much. Happy coding, and see you next time.